All right, in this lesson, we are talking about the square root parent function, and then we are going to do transformations. And so the square root parent function is f of x equals the square root of x. And so if we plug in some x values, square root of 0 would give me 0, square root of 1 would give me 1, square root of 4 is 2, square root of 9 is 3. Okay, and so that means I have the point 0, 0. I have the point 1, 1, I have the point 4, 2, and then I have the point 9, 3. And so this function is going up to the right in kind of a curved shape. And so I specifically chose perfect squares to plug in for my x values, and I didn't choose any negatives. And the reason for that is if I were to take the square root of, say, -9, that would be an imaginary number, which of course would not show up on our graph. And so 0 is the smallest number we can plug in for x. And so our graph kind of has this blunt starting point here at 0, 0. And so that's the point we're going to want to keep track of. And so I just call it the starting point. And right now it's at 0, 0. That's default setting. And then, of course, as we shift it left, right, up, and down, that point could change. And then for direction, you want to pay attention to the fact that it's going up and to the right. Up and to the right. Okay, because when we start reflecting this graph, it could change either of those directions. So default setting is up to the right. Okay, and so jumping down to domain and range, that's what this direction is going to help us find. So for domain, it starts at 0 and goes to the right. So that means it's going from 0 to infinity. And we use a bracket because we do actually reach that point. It's not an asymptote situation. It's not a hole in the graph. We do equal that starting point. And then similarly, for the range, we start at 0 and we're going up. And so 0 to infinity for the range as well. Still bracket on 0, 0. Okay, so something you'll notice is that the x value of the starting point is going to be the starting point of your domain. The y value of your starting point is going to be the starting point of your range. Okay, and then as far as intercepts go, right now 0, 0 is both our x and our y intercept. But of course, as we shift this graph around, if it were up here, it wouldn't have any intercepts. Whereas if it's down here, it's going to have two different intercepts for the x and the y. And so I'll show you how to calculate those algebraically towards the end of the lesson. Okay, and for symmetry, that's actually really easy for square root. There is none. Most of our parent functions do have either like an axis of symmetry or rotational symmetry, but this is really one of the only graphs we see that has no symmetry whatsoever, and it's because of that blunt starting point. I can't really reflect it and look the same. I can't rotate it and look the same, and so no symmetry for the square root parent function or any of the square root functions. And then for a global max or min, because the parent function is going up forever, it is not going to have a global max, but it does have this global min. Okay, the minimum is where that range starts, and so our global min is 0, and we'll want to keep track of that global min when we start finding max and min on intervals. Okay, so that's the parent function. We're going to transform this function. And so just a reminder of our transformation rules. We've looked at them for absolute value. We've looked at them for quadratic. We've looked at them for cubic. And now we're here at square root. And so if you have a +5 outside the parentheses of the function, it would be outside the bars or outside the square or outside the cube. For us, it's going to be outside the radical. Okay, so +5 and -5 outside the radical versus inside the radical, which would be inside the parentheses. So our radical is kind of our new set of parentheses. It's the grouping for this situation. And so these first 4 transformations are all the translations. +5 outside moves us up 5, -5 is down 5, And then as soon as we jump inside the parentheses, we're affecting x, so we're affecting the x direction, okay? And then remember, it's always opposite. So the plus actually moves you left 5, and the minus actually moves you right 5. Anything inside the parentheses is opposite. Okay, here we have a negative outside the parentheses, and so the negative would be outside the square root. And then a negative inside the square root would be the negative inside the parentheses. So outside is our reflection across the x-axis, and then inside is our reflection across the y-axis. So a reflection across the x-axis would make our square root function upside down, whereas a reflection across the y-axis would make it point left. Okay, and so if you see it facing a different, remember default setting is upright, and so it's very obvious when you have a reflection for square root. Okay, now we have our scale factors. And so a scale factor outside the parentheses is outside the radical. A scale factor inside the parentheses would be inside the square root. Okay, scale factor outside is a vertical stretch by 5 or a vertical compression if that scale factor is smaller than 1. I just picked 5 to have an example. That wasn't another letter, but it could be any number. And then here we're inside, so everything's backward. So a 5 is actually a horizontal compression by 1/5. And a 1/5 is actually your horizontal stretch by 5. Okay, and so hopefully all of this is just a review. We've done these since our first unit, and so just recapping them for our summary chart. Okay, and so we can have more than one transformation. We're looking at the scale factor in front to see if it's negative, to see if there's an Rx, or a vertical stretch or vertical compression. We're looking at the scale factor inside to see if it's negative for the Ry, or the horizontal stretch and horizontal compression. We're looking at the H for right and left. And we're looking at K for up and down. Okay, and so the only transformations that affect your starting point is right, left, right, up, and down. And so if I move right H up K, that puts my starting point at HK, which means my domain is H to infinity and my range would be K to infinity, assuming there is no reflection. Okay, and so if B is less than 0, meaning this scale factor inside, we would have an Ry, which makes the domain less than H. If we have a reflection across the x-axis, that's what makes the range switch. Okay, and so let's do some examples. We're going to start by just identifying the transformations for these 4 examples, and then also the starting point, and then we'll get into some other key features. Okay, and so right now for example 1, we have a vertical compression by 1/3. We have a right 7 and an up 6. Okay, so no reflection. So this function is still up to the right, and that starting point is 7, 6. So 7, 6, which means our domain is going from that 7 to infinity, and our range is going from that 6 to infinity because our direction is still up and to the right. Okay, and so for our global max, there isn't one. It's going to infinity, but we do have a global minimum at 6. Okay, for this next function, it's not in proper form, so the first thing we need to do is write it in proper form by factoring out this -2. You just divide the other number that's under the radical by that -2. So that would become x minus 1/2. It doesn't affect anything outside the radical, just the number inside the radical. Okay, and so now when I'm listing my transformations, this negative inside is a reflection across the y-axis. This 2 inside is a horizontal compression by 1/2. This minus 1/2 moves us to the right 1/2. And then lastly, the minus 7 outside is down 7. Okay, and so because of the RY, we are facing to the left. So it's still facing up, but now it's to the left. So up and to the left. And then because we moved right 1/2 and down 7, our starting point is 1/2 -7. We're going to the left this time from that 1/2. And so instead of putting the 1/2 first, we're going to put -infinity to 1/2 with that bracket. You always go from least to greatest. And so if our function is going to -infinity, that should be the first thing you write for interval notation. Okay, and then for the range, it's still going up from the -7. So -7 to +infinity, which means that is our global minimum at -7. All right, so in these next examples, we're going to start putting an interval. So we want a more accurate graph. And so after we identify transformations, we're going to create an accurate graph to include the interval. Okay, and so our first transformation I'm seeing is an Rx. And then I have a scale factor of 4 outside, so we're stretched by 4. And then this -7, notice your square root is ending at the x. So this -7 is outside, that is down 7. Okay, so this time we didn't move right or left, so our x-coordinate still starts at 0, but our y-coordinate would be -7. We do have an Rx, and so just sketching my graph, it's down 7. So my new starting point is at -7 on the y-axis, and it's going down into the right because of the reflection across the x-axis. He's upside down. Okay, and so looking at my domain, it's going from 0 to infinity because it's still going to the right. But then the range is now going from -infinity, and it is stopping at -7 with the bracket. Okay, -infinity stops at -7. Okay, and so for our interval, they want to know between x equals 2 and between x equals 6, what would be the max and min. And so I'm going to graph that interval at 2 and 6. So here's x equals 2, and then here's x equals 6. Okay, the reason why you want to have this sketch is because your graph could maybe not even exist on the interval. For this graph, it does, but depending on where we move the square root to and which direction it's facing, it may not even exist. So some of these values won't exist. Here, we're going to have both. Okay, so our function is decreasing, and so I know my max will occur at the 2, and I know my minimum will occur later at the 6, because this function is going down to -infinity. Okay, and so when I plug in x equals 2 to the function, I'm going to grab the function rule, -4 square root of x minus 7, and we're going to plug in both of those values. So plugging in the 2, plugging in the 6, and these don't turn out to be nice values because, of course, 2 and 6 aren't perfect squares, and so we can use our calculator to get the decimal approximation. For a non-calculator test, you would just leave it in terms of its square root. Okay, and so -4 square root is second, and then that square button. 2, and then you use your right arrow to get out of the radical, minus 7. Okay, so approximately -12.66, and that would be our max. Okay, and then for the min, we're doing -4 square root of 6, and then get out of the radical minus 7. and that's negative 16, which makes sense because it's smaller. Negative 16.79, and that would actually round to 80. Okay, and so that would be our minimum. And so those are the values you would answer for those questions. All right, for this next one, again, we don't have good form because there's a number outside the radical with a scale. There's a number inside the radical with a square root inside the radical. And so we would need to divide that by 1/2. Dividing by 1/2 is the same as multiplying by 2. So we would actually have an x minus 4 sitting there. If you were to type this in your calculator, you would see that it's actually moved right 4, even though you're seeing a minus 2 here. It's always important to get the scale factor away, factor it out. Okay, so listing my transformations, I have a reflection across the x-axis. I have a horizontal stretch by 2, and then I have a right 4. Okay, so this time we didn't move up or down, just to the right 4, and so we would have 4, 0. We do have another reflection across the x-axis, and so as I draw my graph, I'm going to draw it to the right 4, but it is upside down. Okay, and so my domain is still going from that 4 to positive infinity because it's going to the right, but my range is going down. So it starts at 0, starting at 0, y equals 0, and going down. So we actually need to put the negative infinity first, always least to greatest. Okay, and then our interval is from 0 to 8. And so from x equals 0 to x equals 8. So x equals 0 is right here on the y-axis. X equals 8, 5, 6, 7, 8 would be here. So now when you're looking at our function, I can't even plug in x equals 0 to the function because our graph doesn't exist over there. But looking at our picture, we can see our max, our global max falls on the interval. So that's automatically your max. And so your maximum value is 0, and it occurs at x equals 4. Okay, it's not at the end point. Our function doesn't exist at the end point. And so that's why you need the picture, because now you can see your maximum value of this function is your global maximum. It's 0. So your max is 0. And then our minimum is going to occur at the 8. Okay, so we don't have to plug in x equals 0. We're going to get something that is an imaginary number, but we do need to plug in the 8. So grabbing my original function, and I'm actually going to grab the one before I put it in proper form, just because there's less parentheses. And so y equals negative square root of 1/2 x minus 2, and we're filling in the 8. Okay, so 1/2 of 8 is just 4. And we still have a minus 2 under the radical. And so that simplifies to a negative square root of 2. And so I'm going to leave it in terms of the radical. So our minimum would be negative square root of 2. Okay, these next examples, we're going to practice finding the x and y intercepts, which we've been doing for all of our other functions. Remember, for the x-intercept, you are plugging in y equals 0. For the y-intercept, you're plugging in x equals 0. The y-intercept is easier because you're just number crunching. So I'm going to start with the y-intercept. And so for the y-intercept, we plug in x equals 0. And so that gives me 0 plus 4 under the radical minus 3, which is square root of 4 minus 3. Square root of 4 is a nice number. It's 2. And so our final answer is negative 1. Write it as an ordered pair. That's always best practice, is to write your intercepts as ordered pairs. Okay, so there's my y-intercept. And then let's go ahead and find the y-intercept for number 6 as well. Okay, so for a y-intercept, your x is 0. So negative parentheses 0 minus 3 and then a plus 4 outside the radical. Be very careful whether you're inside or outside the radical. That's often a careless mistake I see. 0 minus 3 is negative 3, with that negative still there. Negative 3 is positive 3. And square root of 3 is not a nice number, and so we're going to just leave it in radical form. So 0, comma, square root of 3, and then a plus 4 outside the radical. You would miss it if you wrote that plus 4 inside the radical. Okay, now for our x-intercept, we're plugging in 0 for the y. So we're going to have square root of x plus 4 minus 3 equal to the 0, and we need to solve this radical equation. So your first step is to add 3. Get rid of what is outside the radical. So I'm going to add 3 to both sides. And then now everything is under the square root, so we're ready to get rid of the square root by squaring both sides. Okay, and so when I square both sides, that leaves me with x plus 4 without the radical, and 3 squared is 9, and then we subtract 4 from both sides to get x equals 5, and so we would write our x-intercept as an ordered pair, 5, comma 0. The y was 0. Okay, for this next one, same idea. We're plugging in 0 for the y. And so that gives me square root of negative x minus 3, and then a plus 4 outside equals 0. First step is subtract 4 from both sides. And then you should immediately see something wrong here. When I take the square root of anything, it's going to be a positive number. I don't have a positive negative out here. Square root, a positive square root cannot equal a negative number. Okay, and so you could square both sides, but you're not actually going to get a viable solution because this can't happen. You can't have square root equal to a negative number. We talked about that. We talked about how the range was greater than or equal to 0. And so square root cannot equal negative. And so this would be a case where we do not have an x-intercept. And so for the x-intercept, you would say none. Okay, and if you think about how this graph would look, just looking at our transformations, we have a reflection over the y, and it's moved right 3 up 4. And so my starting point, right 3 up 4, and then reflected across the y, it's going to hit the y-axis at this value, but it's never going to hit the x-axis. So picturing it graphically, you can see, oh yeah, there's no x-intercept here. And then algebraically, you can see that you end up with positive square root equal to a negative number, which can't happen. All right, last thing we're going to do is write an equation given the transformations. So it says write the equation for g of x if g of x is formed by reflecting our square root function across the y-axis. So that means my negative is inside. And then we have a horizontal compression by 1/2. So that means I have a 2 inside. That's my b value. And then left 3 means I'm going to need a set of parentheses, so it's proper form. I'm going to have an x plus 3. And then lastly, the up 11 would be completely outside the radical for plus 11.